Hello, tonight our video is on rate of change again. This is part 3. So in rate of change problems, what we're looking at is a graph that represents some situation. And we're looking at how that graph is, the direction that it's going. So for instance, here, this line is going upward to the right. So this rate of change is a positive rate of change. As each hour goes by on this graph, as we get from 0 to 1 on the x-axis, then the value of y increases from its initial value of 0 up to the value of 5. And as we go from 1 to 2, the value of y changes from its value of 5 up to the value of 10. So you can see, we had this in a previous video, that the rate of change is plus 5. As we increase each value of x by 1. All right, so this is a positive rate of change. And it would be shown in the equation by putting the 5 in front of the variable x. And since the initial value of y in this case, when x was 0, the initial value of y is also 0, then we could put plus 0 to show that, but we really don't need to include that in our equation. This is the equation that this line represents. All right, so it's possible though to have lines that go the other direction, that go downward. So for instance, you could have a line that has an initial value of say 15 and then it starts decreasing by 5 as x increases by 1. So this would look something like that. Oh, it's time for me to stop, huh? No. So this situation, the rate of change would be a minus 5 because as x increases by 1, y is decreasing by the value of 5. All right, so that equation would show that there's a negative 5 in front of the x. And the initial value when x is 0 for this example is at 15. So I'd put a plus 15 here to show that. So this would be the equation for that second line that I just showed. All right, so now let's go to the next slide, and the remainder of our video will be dealing with a problem where we have this negative rate of change. All right, so let's read the problem and work it through. The Kia Forte averages 30 miles per gallon and has a 13-gallon tank. The Toyota Camry averages 25 miles per gallon and has a 16-gallon tank. If both cars start with a full tank, show how the amount of gas left in each tank is a function of the number of miles driven. Graph your results. So here I've set up two tables, one for the Kia and one for the Toyota. So notice that the x-axis on our graph, which is down here, the x-axis represents the miles the car has driven. And the y-axis, which is going to be a function of the miles driven, represents the gas left in the tank. So let's start with the Kia. The Kia starts with how many gallons in the tank before any miles have been traveled. So in other words, miles traveled is 0. How many gallons would be in the tank? That's right, it'd be 13, right? Because it has a full tank. So 013, the point 013 would be on our graph. Right there. All right, so let's go ahead and graph. Why don't we use nice round numbers? Let's say, or numbers that would be advantageous for us to use, easy to work with. So let's see. The Kia gets 30 miles per gallon, right? So for every gallon used, for every 30 miles traveled, the tank will go down by 1 gallon. So let's say that the Kia goes 120 miles. How many gallons will it use up if it goes 120 miles? Well, if you divide 120 by 30, it would use 4 gallons of gas, right? So that means the tank would now go from 13 to 9. And notice that I used an X value that's going to give me a whole number and easy to work with and easy to place on my graph. So on my X-axis, 120 is 1 mark past the 100. And then at that point, 9 gallons would be in the tank. So we're looking at our point right there. See that? That's the point. X equals 120, Y equals 9. All right, and so I think that if I just use the same multiples again, if I go another 120 miles, that means the Kia has now traveled 240, and the tank goes down by 4 again. So I'd have 5 gallons left. So 240 is 2 marks past 200, and 5 gallons would be right there. See that? See how I'm being, clever about which values of X I use? I want to use something that's going to be easy for me to graph. And let's stick with it. Let's go another 120 miles. That would be a total of 360 miles. And how many gallons would be remaining in the tank for the Kia? That's right, it'd be 1, because we used another 4. So 360, 1 is right there. There's the point. X equals 360, Y equals 1. All right, so that would be my graph, and I'll try to draw as straight as I can. That would be my graph for the Kia. Okay, so now let's graph for the Toyota. Again, we'll start with 0 miles traveled. How many gallons in the tank? That's right, 16. So the point 0, 16 is right there. Okay, and so now I want to use multiples of 25 for X because that's the miles per gallon the Toyota gets, right? 25 miles a gallon. So let's say the Camry goes 100 miles. How many gallons will it use? Well, 100 divided by 25 is 4. So yes, it would use 4 gallons. That means there'd be 12 gallons remaining. So X equals 100, Y equals 12 is right there. Okay, so let's be clever about it. Let's just go by 100-mile increments. So when X is 200, how many gallons would remain? That's right, it'd be down another 4, so it'd be 8. So 200 and then 8. Okay, so now let's use 300 and 400. So 300 for the miles traveled would leave 4 gallons, and then 400 miles traveled, oops, that would give us an empty tank, right? So let's plot those. 300 for X and 4 for Y, and then 400 and zeros right there. Okay, so there is my graph for the Toyota. All right, so how'd you do on that? Does that make sense? Okay, great. Now that we have the graphs for the Toyota and the Kia, let's write an equation or a rule to represent the graph. Remember, when we write our rules, that we write with the variables y and x, so we have y equals, and then y will be a function of whatever x is. The number in front of x would represent the rate of change, and then the number after x would have to give us the initial amount when x is 0. So for the Toyota, if y represents the number of gallons left and x is 0, well, no gallons have been used up, so the initial amount would be the full tank of 16 gallons. So plus 16 has to go here for our equation, for our rule. Now, the rate at which the number of gallons is decreasing is dependent upon the number of miles, and that rate is going to be, first of all, it's going to be negative because the gallons are going down, right? It's going to be negative, and the rate is going to be 1 gallon for every 25 miles. Okay, so when x is equal to 25, that means that you're going to lose 1 gallon of gas. So here is our rate that the gas is being used up. So that fraction, negative 1/25, goes in front of the x. Kind of squeeze it in there. Okay, hope you can see that. All right, so now let's write the equation for the Kia. So again, y equals something x plus the initial amount. All right, so the initial amount of gas for the Kia is 13, so this is going to be plus 13. And the rate at which the gas is used up for the Kia is minus 1 gallon for every 30 miles. So negative 1 over 30 would go in front of x. And we can test it out. Okay, if x equaled 30, then negative 1 over 30 times 30 would equal negative 1. And negative 1 plus 13 would equal 12. So 1 gallon would have been used up. So here are the two equations, rules, if you will, that match the graphs. Remember, read some books.